Hi everyone, this is Elisa Baum, Percona's Director of Product Marketing. We'll begin in just a moment, but I'd like to conduct a bit of housekeeping. Could you please raise your hand using the hand icon located into the GoToWebinar control panel to let me know if you can hear me okay? And let me see, do I see hands? I do, thank you very much, audience. Let's see, next during this webinar, you will be on mute. Should you have any questions during the discussion, please go ahead and enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible, and those that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL Performance blog. In addition, a recording of this webinar and slides will be made available to everyone within 48 hours. With that said, I'd like to thank you for attending today's webinar, MySQL Replication Best Practices. It's being presented today by Francisco Bordenave, who is a Percona MySQL consultant. And with that said, go ahead, Francisco, you have the floor.
Okay, thank you very much, Elisa. Welcome, everyone. Today we will be talking about best practices on replication and how to set up a replication environment using proper variables and setups. Okay, here's the agenda. We will start with some overview of how or what is replication, what I call replication in a nutshell. Basically, we will be talking about the replication components. Then we will be going through how to set up and set proper values for proper variables. Then we will check how to monitor replication, especially what we need to monitor and what to check. Then we will check about the data consistency check-ins. Normally the replication is something that you set up and never take care about what is happening there. But what if we have problems? For that we will cover how to synchronize data. And finally, we will do an overview on GTIDs and how to implement GTIDs in a running environment. All right, let's get started. Replication in a nutshell. What are the components? We will talk about the binary logs and what the replication threads need to be considered in a replication environment. First of all, we have this little graphic with the components that are considered minimal for a replication environment. We will have at least 2 servers, one master and one slave. For replication environments, of course, we can have a lot of slaves. Replication is very flexible in that regard. Each server has its own functionality. For master, we will consider that server that is accepting requests for write and reads from any of your applications. Okay, and then for slaves, we will consider that server that is connected to master and getting all changes replicated to itself. Okay, the master has a couple of components besides what we may consider the application or client that connects to master. It creates some files for each replication environment called binary log files, where each change that you do in the data, and for this you need to consider write operations in your master. All select operation or read operations in master are not logged to the binary logs. And these files are being used by the slave to create a copy of them called relay log files that is used to
Francisco, your voice went out. Yeah, Francisco's calling in from a remote location, so give him a moment, please. I apologize for the inconvenience.
binary log. We can have 2 different types of binary log.
Francisco?
Yes.
Your sound
yes.
cut out the previous slide. Could you please go back and repeat it?
Yes. Okay. Where you lose me?
I believe it was this slide here.
Okay, yeah. Okay, last thing I was saying about the slave files, besides the relay log files, which is basically a copy of the master binary log files, we will have two more files called master.info and relaylog.info, which contains some information about replication status. We will cover that later on. About binary logs, these files are, binary files which contains all changes done in the master data. We can have two different types of binary logs depending on the format we configure the application, the master server, sorry. It may be statement format or log format. Basically, the statement format will store all the queries as it were executed on the master, okay? So if we read this, and if you can see my cursor, you will see an insert command that was run on the master, and that's it. It will be replicated as it is on the slave. And then we have the raw format, which will include this format of each event that is run on the master, okay? It's binary. You cannot read that unless you do some kind of translation from the raw format. And you can have, in previous version than 5.6, you will find that all events are stored in this way as a comment. And then from 5.6, there is a variable that you can configure to increase the verbosity of each event that will store also the query you run. So let's say that 5.6 allows us to understand better what's going on when we are reading the binary logs. I forget to mention, but the binary log files can be read by an application that is delivered in every distribution, which is called MySQL binlog. And that is the tool you can use to read the contents of a binary log file. Otherwise, you will see just garbage. Okay. What threads are involved in a replication environment? The master that opens a thread per each slave that is connected. This thread is called binlog dump, and basically this thread is a thread that reads the contents of the binary log file and push these changes to the slaves. You will see this thread running only when a slave is connected to a master. So if you don't have any replication slave running, you won't see anything on the master running. But if you connect one or more than one slave, you will see one thread per slave doing binlog dumps. At the slave side, we mainly have two threads. This is per slave, okay? So each slave will open two threads. One is called the IO thread, which is the one that connects to master and gets data from binary logs. It also creates the relay log files in disk. So the IO thread basically will copy over the file from master to slave, and also will update the coordinates on the information on the relay log events in the master.info file in the slave. Then you have the SQL thread, which runs locally. It reads files, contents from files in the relay log events and applies them into MySQL. So the big difference between these two threads is that IO thread only copy data over from the master to slave. It doesn't change any data within the database. And then we have the SQL thread, which actually applies these changes. So either you can have both or any of these threads running in a replication server. And they are kind of independent from each other. Okay, let's talk about the variables that are involved in a replication environment. In the master, the first important variable that you need to set up is the server ID. This server ID is an integer value that identifies each servers on a unique way, and this is mandatory to have a replication environment running. If you don't have this variable set, the replication won't work, and MySQL will refuse to start replication without having this variable set. Then you have this logbean variable. Logbean instructs the master to create binary logs, which by default are off. And these binary logs are, of course, necessary to create or copy all the database changes to each slave. So these two variables are not only necessary, but mandatory to create a replication environment. And the question is this enough? Yes. Practically, yes. With these two variables, you can have a master that is ready to replicate. But there are some other variables that we need to define to make things work properly. Number one is the bin log format. As we discussed, we have two different types of binary logs, statement and row. But this variable can take an additional value, which is called mix, which in practice is statement unless I found some query that may cause problems in the slave, especially for those queries using non-deterministic functions. So I will try to be more clear here. If you run a query that modifies data, but this query is what we call non-deterministic, for instance, if you run this in master and run the same query in the slave, it may produce different results, then MySQL will try to pick row mode if we are using mixed mode in the binary log format. So we will produce changes per row instead of running a big statement. I will cover what is recommended. There is an historical discussion about that, but this is basically the way we can configure the binary log bin log format. Then the variable called logbean we will already cover. You can define this variable also using a base name, which you can set up where and how to store these files. I mean, where in terms of path, if you want to store the binary log files in a different location than the data dir. And also you can define the name of these binary log files. By default, these files are stored within the data dir, and the default name is host_name.bin. It's a good thing to create different values for this, especially when you have a lot of servers, so it's easy to identify the files. There is a third variable that I'm covering here called bin log rows query log event. This variable is what we discussed about making binary logs more verbose when we are using row format. But this is only available from 5.6, so this variable cannot be used in previous versions. Finally, we have two more variables. Of course, there are a lot of them that we won't cover in this session, but these two becomes important because I have seen this used a lot, and I would like you to consider avoiding using this. Binlog UDB and binlog ignoreDB basically tells MySQL to filter events corresponding to a certain database. You can set up these variables naming one of several databases within your master, and MySQL will use that to filter events and avoid storing them. All right, on the slave, sorry. Let's go back a bit. Okay, so this is what we will set up in the master. I will cover this a bit better later in the session. Then we have variables on the slave. Again, server ID becomes important to make MySQL run in a replication environment. Otherwise, it will default to 0 and when MySQL finds it has server ID equals 0, it won't start replication. Logbean, in this case, Logbean is optional because you don't really need that to make a slave run. But it's recommended to have binary logs created and stored at the slave side because it will help to create replication chains. For instance, master, then a slave from this slave, or for backups, for checking what's going on when you have problems with your server and so on. So I strongly recommend to use the Logbean at the slave side too. The other variables, we have seen some of them. Bin log format, again, about the format we are going to use in the binary logs. The Logbean base name to name our files. Log slave update. This is an interesting value that only works at the slave side and will tell MySQL that it has to store all commands that been running by the replication thread, by the SQL thread. If you don't enable this variable, MySQL will only write to binary logs changes done out of the replication stream. That means clients connecting to the slave and running write queries. So normally this variable, of course, is by default is off. And normally when you enable only the binary log in the slave, you will see very small bin log files without any kind of activity, even if the slave is running. That is because log slave update is disabled. The relay log file or the relay log variable works in a similar way that the Logbean. It will instruct MySQL how to name and where to store these files. You can use exactly the same way as Logbean. You can ignore this variable in the setup. It's not mandatory. The replication will work as well, but it will store the files within the data dir and using hostname.relay for naming that files. There is another variable here called expire log days, which is the variable that defines how many days you want to retain your binary log files involved, master and slaves. This variable by default is set to 0, which means that all your files will remain forever. And it's very common to see problems in the servers because of the disk usage caused by this variable not being set properly. Finally, we are covering some filtering, which is the recommended way to do that. We can filter events coming from master at the slave side. For instance, if in the master you have a database that you don't need on the slave, you can instruct the slave to say something like, okay, ignore these events coming from this variable, from these databases. Replicate doDB, replicate ignore DB, replicate while to use lookups based on wildcards or what we call not regular expression, but something like that. And you can do this at table level, even at table level. So the granularity is very, very high. You can filter from database to even tables. Okay. What I call best practices for this. Okay, this is something that came to discussion after a long while dealing with replication. I recommend to enable binary logs on the slaves, as I mentioned, having Logbean, log slave updates, and expire log days at the slave side. It's not mandatory, but it's something I would recommend, strongly recommend, because again, whenever you need to do some forensic or backups or activities that you need to use the binary logs, it's it's important, and it's also very helpful to have binary logs created at the slave side. Something I forget to mention about the binary logs, which is one of the most important features for them, is that in MySQL world, the binary log files are the only way to create point-in-time recovery when you are doing backups, because it stores all changes happening in a database even after you check your backups. So even you have backups taken 1 per hour, something like that, you will have up to 1 hour of possibilities to lose data. And the binary logs will help you in that regard. So I always recommend to have this enabled. Another one thing to consider best practice, create crash safe slaves. In Percona Server 5.5 and then in MySQL Community 5.6 and all the derivative versions, there were a change called crash safe slave that basically will allow you to store the data from replication information in tables, in InnoDB tables, instead of using files. Okay, so if we use crash safe slaves, we will avoid using the master.info and readelog.info files, which will allow us to survive a server crash, because these tables are crash safe. Remember, they are InnoDB, so having this information inside a table will allow us to go back to work after a slave crash. Another recommendation I have here is to try to filter events at the slave side, as mentioned, using these variables, replicate ignore-db and replicate while ignore-db, instead of filtering events at master side. The being log ignore-db in master side is, from my point of view and in my honest opinion, is bad. You should avoid that. And finally, we have 2 more things to be always on the safe side. These 2 variables will avoid replication. Number 1, read-only, will avoid someone to write on the slave, because read-only only allows user with super privileges, normally the root user, to write on the slave. So if you don't have enough privileges, or you only have insert or delete privileges on a table, if the server is read-only, MySQL will avoid you to run commands there. And the other one is escape slave start. This is a good practice on all replication environments, because if you have a crash or if you have an accidental restart or whatever, you don't want MySQL to automatically start replicating data from master, because you want to know what's going on in slave. And I consider these 2 almost mandatory on all slaves. Okay. One important thing about the read-only variable, you can still run queries on the slave, like reporting queries. You can still run selects and so on. So putting this in read-only mode, it's very good from my perspective. Okay. How to set up replication? Let's start from the configuration files. As mentioned, in the configuration file, which is the mat.cnf file, depending on the distribution, it might be located in different places, but normally / etc. is the regular location when you can find it. You need to use, as mentioned, server ID, log bin to enable the binary logs, expire log days, and bingo format. Again, there are optionals, but I recommend to use raw format and expire log days at something like 7 days or something like that. I mean, I don't recommend you to go further from that because binary logs in this environment can take a lot of space in disk. Then at the slave side, notice that I'm changing the server ID to 2 because we want to have a different number than master, but you can use whatever number you want. As long as it's different from master, you can pick whatever you want. And this is, if I recall correctly, this is a big int number which can go up to several thousand millions of number. So I cannot remember what is the limit here, but you have a lot of numbers to pick. Okay. As mentioned, read only and skip slave start. Log bin to create binary logs at the slave side, and log slave updates to make replication stream to push changes into the binary logs. In this case, we are creating crash saves slave, which is using the master repository and the relay log repository in tables. And we are pushing the relay log recovery in one, which after a crash will reread the events that was already run and compare that with the status of the relay log files to know if it needs to re-download the files from master. It's a bit complex how it works, but it adds some security to the slave to avoid a slave running events that might be inconsistent or corrupted. Okay. We have the configuration files. Then we need to set up the slave. Okay. How so? On the master, we need to create a replication user because, as mentioned, the slaves connects to master as a regular client. There are no differences in terms of connections from a slave or any application, besides some different privileges that you need. The way to create the replication user is with this command: run replication slave on start.star to user at host. And you can use identify by password. The password, of course, is anything you want. Once we have this replication created, we need to create a backup from master. For this case, I'm going to use two different methods, MySQL dump or extra backup. MySQL dump is delivered with the regular installation, so you can use that by default. In non-busy servers, and when you have small databases, like a couple of gigs or something like that, MySQL dump is normally a good solution. But if you are creating a slave from a very, very busy server, and this slave and this database, this server is huge in terms of size, I recommend to use extra backup because it won't lock your tables, which in practice is good to have the server running without problems. One particularity of MySQL dump is that you need to use this flag /master-info equals 2, which will store the binary log position in the backup as a comment in the backup file. The output file is a text file, so you can query that or read that with any text tool. But master info will be located at the top, I don't remember, but like 30 rows or something like that in the backup file. Extra backup by default stores the information about the binary log position. We will cover that in a particular file, so you can just check the file contents and you will see what's the status or what's the position to start replicating from. So once we have the backup created, we can move to restore the backup on our new slave. Of course, I assume that you copy all the data or the resulting files, either the backup.sql file created by MySQL dump or the whole folder that extra backup is creating. So when you restore using MySQL dump or using a backup coming from MySQL dump, you only need to stream the file into the MySQL client, as it's done in this example. Very easy, MySQL -u root -p, which is the password, and just redirect the backup.sql file inside that. And once the backup or the restore is done, you need to check the backup.sql file for this line, change master to master log file. That will tell you where exactly was the replication, where exactly were the binary log position, file and position in the file when the backup was taken. For using extra backup, the process to restore is a bit more complex. First of all, you have to stop MySQL and clean up the whole data dir. Then you need to copy over all files from the backup folder inside the data dir and change the ownership of the files. Normally, extra backup is run using root account, so files will be owned by root. You only need to change the ownership and then restart MySQL. In the previous step during the backup, there are instructions on how to prepare the backup to make it usable. So at the end, it's only a copy of files inside the data dir. Then you can restart MySQL, and the binary log positions are stored inside the extra backup _binlog_info file. That's all we need to start replication. Or in other words, this is all steps we need to do at the master and to prepare the slave to be able to start replicating. The third step is actually creating or instructing the slave on how to start replicating. So basically, we will use a command called changemaster2, which accepts a lot of parameters, but we will use just a few of them. And with this command, you will tell the slave which host to use as master, and authenticate with this user and this password against this master, and start replication from this binary log file and using this position. So basically, the command is change master2, master host, master user, master password, master log files, which is binary log, and master log post, which is the position. Once you run this command, then you just run start a slave, and that's it. You should have a replication slave running without any problems. The entire process is pretty straightforward, so it shouldn't be problematic if you follow this instruction. Okay, monitoring replication. Basically, what we need to monitor in order to see if our replication is working properly. There is a basic manual check with the command show slave status. This command will throw, depending on the version, a very big output with several data, several fields with some data. And we actually need to take care of 3 of these. Slave IO running, slave SQL running, both needs to be in yes, which means that IO thread is connected and dumping data from master, and SQL thread is reading the relay logs and applying data properly. And then there is a third value that we need to monitor called second behind master, which shows how much is the lag against the master, or how far is the server lagging behind the master. One thing that is worth to mention is that replication is considered or works in a single thread. So all the events are applied in a serial way, while master accepts concurrency. So in practice, this means that if you have a very high load master, you will most likely have a slave that lags behind master because it is not able to apply all events in a proper manner. Besides this basic manual check, we have some advanced manual check using a tool from the Percona toolkit that is called pt-table-checksum. pt-table basically will create and store records in the master using some timestamp-based values, and then check these values in the slaves to compare how long they take to go from master to slave. This is way more accurate because this is real lag. If I insert a record in the master, how long it takes to reach the slave. Using this tool in the master as demonized, we'll keep it running forever, inserting data in the master, and then you can use the sorry, the -- monitor flag in the slave to check the replication lag. Besides this, there are some free tools that you can install in your system, which has already plugins to monitor replication. Some of them, the more known of them is Nachos or Cacti or Moving, but there are a lot of them. Some free, some other are paid versions, but I can count hundreds of them. Okay, how to check data consistency? Wait a second, please. What if something happens on the slave because someone with super privileges run a query that modifies data on the slave? Or what if our events are not applied properly on the slave? Okay, one of the best practices for this is to periodically run checksums, or yes, check of data. How? Using a tool called pt-table-checksum. Let me give you a disclaimer. Please download these slides from our website and try to digest this at home, because some information here can be a bit confusing. But basically, what I'm doing with this pt-table-checksum tool, is to run checksums on each table and master, then run checksum on each table and slave, and compare results. If checksum is the same, we won't have any problems with difference. But if we have differences, this tool will inform about them. In this case, we are using the Sakila database, which is something you can download from MySQL website. We found, because in my test I have introduced some changes manually. In the slide we have that Sakila.film table has two differences. This is not 2 rows, but 2 chunks, which may include a lot of rows. And in order to get a more readable output, instead of using the default output, we can use the flag, run the tool a second time with the flag --replicate check only, which will query the table where we store the result of checksum and provide the tables that has found differences. In this case, only Sakila. Okay, we found problems. What we will do next? We will sync up the data. How so? There is another tool that is called pt-table-sync, which is a very interesting tool that will, in this case, use the information provided by pt-table-checksum to find out what are the differences. But in this case, it will rerun the checksums and find out which rows have differences between master and slaves. Of course, this tool is a tool that actually modifies data. So I normally recommend to use that using the --print flag and also verbose to make sure that the changes we are going to do are correct. In this case, it only will print out which commands it will run, but it won't run nothing actually against the master. These tools normally updates records in the master and let them replicate to slaves. So it's very safe to use because it won't set the same values that are already stored in the master. Finally, this tool, when we change the flag from --print to --execute, will run the commands that were shown in the previous output and report what changes has done in each table. When using the --execute, the output will be less verbose, but we have a good summary at the end that will help us to understand what we have changed. Okay, let's move to GTID. Short overview of what GTID is and how to deploy it. Okay, this is the last portion of our talk today. Okay, what's GTID? GTID is a global transaction identifier. What it means that it is a good way to identify a single transaction along a whole cluster or a replication environment. Each event stored in the binary log will be stored with GTID value, and this value is done with two sub-values, let's call that way. One is the UUID, which is a server identifier. This is created when the server is started, and it remains the same for the duration of the server. And then we have the transaction ID, which identifies the number of the transaction coming from this server. This has some advantage. It ensures that transactions belong to only one server, so we cannot find the same GTID in different servers. Also, it ensures that transactions are applied only once in a replication stream. With some odd environments like having master-master with active datasets or things like that, we can avoid what is called the circular replication, or in other words, a command going to a different server and coming back to the first server and running again. Also, this GTID allows us to easily promote slaves to become master, which without GTID can be a bit hard. How to deploy the GTID? There are two variables that you need to use. One is called enforce GTID consistency. It will instruct MySQL to allow only transactions coming from transactional safe statements. It's a bit hard to explain, but basically transactions that can be reproduced. And GTID mode on, which enables GTID at the MySQL side. Again, is this enough? Well, not really. Currently, my GTID cannot be deployed in a running environment, not in MySQL community version. So there is a procedure we need to follow, which basically means put everything all the replication, enable the variables, start the master first, then start the slave using this command, which is very similar to the command we use to start replication, but in this case, instead of instructing the slave with the position of the binary log, we will tell the slave use master auto position equal 1. This is probably the most interesting feature in GTID. You no longer need to use binary log positions. You only tell the slave, okay, auto position equal 1, and the slave will find out where it needs to start replicating from.
Francisco,
on,
Francisco,
we can resume our applications to use our server.
Francisco, can you repeat
Yep.
the last couple of sentences? Your sound went out. And again, audience, I apologize. Francisco is calling in remotely from a client site. Okay, go ahead.
Okay. Yes, the last couple of sentences, I say that the most important property is a new variable called master auto position. It's not a variable, it's a parameter actually. Allows us to avoid using binary log position.
Okay, I think we've lost sound altogether. Just give it a second for him to get back. He's dealing with ISP issues from where he's located. Apologize again. Francisco, can you hear me? Okay. I wish I knew some good jokes in the meantime, but I'm just really not funny today. Francisco?
Can you hear me?
Yeah, Francisco, you completely lost sound.
Okay, can you hear me now?
Yeah, go back again a slide, please.
Hello?
Yes, I can hear you. Can you hear me?
Here?
Yeah, go back one more slide.
Yes, okay. Here? Or here?
There. Yeah, this is for the slide where
Okay.
Yeah. It might just make sense to do a quick recap of this one and then move on. But thank you so much, and I realize that you're struggling with your connection. Okay, thank you, audience. Here goes Francisco.
Sorry about that. Okay, so basically what I was saying on deployment is what are the steps and what is new in GTID to make the deployment of a slave easier. Basically, the big change or the bigger change here is the usage of a call master auto position, which instructs the slave to auto-discover which position to start replicating from. So in practical terms, we no longer need to take care of binary log files and binary log positions. But as I mentioned, this might not be possible to deploy in a running environment because it requires downtime, at least as MySQL is right now. So in Percona Server, we have ported a functionality coming from Facebook, which is called GTID Online Implementation. What's needed for this and how to deploy it? It's very easy. Number one, what we need, Percona Server 5.6.22 is the first version that supports this change. It will be available in in MySQL Server 5.7, but this version is not GA yet, so we cannot use that in production, or we shouldn't use that in production. And the only change in variables that needs to be set up is this one called GTID deployment step equal on. That's the only change in terms of variables, but we will need a couple of things, a couple of things extra here. Number one, a slave that be promoted to use this slave of the master. It's not the application, but yes, that's at least what we need to make changes. How we deploy GTID online? Okay, on the slave we need to stop replication. Of course, have GTID configure, assuming that not already, of course, and restart the slave. How so? Using this variable called GTID deployment step equal on. This variable drops the slave to allow GTID comments coming from another server, but it won't create its own GTIDs. It's a bit hard to explain in a deeper manner, but basically it allows a slave to connect to a different slave, a different master that is using GTIDs. And also, in this case, we need to allow the old master to connect to this slave as a new slave. Okay, so replication command still applies here. Once replication is up to date, of course, because we connected the slave, the master as a slave, we can change the application to do. Finally, in all the slaves, we need to do the same step, the same procedure. Setting up GTID, restarting the slave, allowing GTID deployment step equal on, and in this particular slave, because we will be receiving GTIDs from the old master, from the new master, sorry, we need to set up master auto position. And finally, once everything, the GTID deployment step, we basically will instruct the servers to create its own GTIDs every time you modify data locally. Okay, that's it for me. Do you have any question on this?
Hi, Fernando. Yes, there's a lot of questions, so I will go ahead and read them to you. And then, audience, just if we don't have time today to get to your questions, I'm going to send Francisco the entire list, and he'll make sure to get them answered in a follow-up blog post on Percona's MySQL performance blog. Also, I will send you a link to the recording and the slides within 48 hours after I process the recording. Okay, let's start in with the questions. All right, I'm looking down the list. Okay, this is a question that it was answered, but there was a follow-on question, so let me just read it to you. Is it possible to set expire log days on the master? Does it make sense to do so? And he wrote, well, the previous question was answered. However, does it make sense to set expire log days on the slave? The slides were a little bit confusing on this point.
Yes, indeed. Actually, I forget to mention, but this variable can be deployed either in master or slave. It only affects binary log files. The files are automatically imported once they are processed. So yes, I recommend you to set up expire log days in both server, master and slave. Normally, the amount of days you want to retain your binary logs, each day you are taking your backups. So if you have a weekly full backup, you will want to store binary logs for 7 days.
Okay, the next question. Why is row-based replication recommended?
Well, the general answer for this is that it's safer because you are changing the difference between only change values in the rows that you are affecting. Instead of running queries that may affect a lot of rows in a single shot, you are just changing one time. It's considered a way to introduce or to replicate changes to slaves because, again, it will affect only each row at a time. So the big difference between row and statement is that some values, normally those come from old queries like, I don't know, insert into table, select from table X, order by run, or order by, which will not give you the same result in master and slave. Use role-based for this kind of environment. It's normally safer to keep replication or accepting the slave.
Okay, the next question. Is it necessary to enable or keep bin logs on the slave?
Not necessary. It's optional. But I would recommend you to do that. For replication, strictly speaking, replication, you don't need to enable binary logs on slave side. But you most likely will need that if you are using this for taking backups, for instance.
Great. Okay, the next question. Can we use the sync table tool on a scheduled basis to replace the replication process?
Can you repeat the question, please?
No problem. Can we use the sync table tool on a scheduled basis to replace the replication process?
But again, the sync tool is something that will write data into your master. So I to use that in a scheduled basis, you may end up overwriting your data. So what I recommend you to do on a regular basis is to run the checksum tool and only run the sync tool if you found differences.
Okay, the next question. Does MySQL failover work with GTID as expected?
Yes, normally, yes. Easy because you only need to change the applications to start writing in a different slave, in a different server than the master. But this failover is not done automatically. You have to take care of the failover, either by running a manual change master 2 with auto position equal 1, or using some external tools like MHA or PRM, which are tools that are designed to automatically failover replication slaves. But from a strict perspective on the replication, yes, if you just change a master to a different slave using master auto position, it normally works correctly without any issues.
Okay, we have time for just a couple more questions, and there are several more. So as I said before, we'll get these addressed in a follow-up blog post. Okay, so the next question is, what are some troubleshooting views to use when trying to establish replication?
Can you say it again? I didn't get that properly.
Yep, no problem. Just have to find it. Okay, what are some troubleshooting views to use when trying to establish replication?
I'm not quite sure what you are referring to with troubleshooting views. Can you explain this a bit better so I can get the question better?
Okay, so Tom posted this question. Tom, if you could just elaborate, and again, I'll be sure to ask the question. All right, so let's see here. How do you fail over to the slave? Is the slave in read-write?
It doesn't matter, because if you are using, setting a slave in read-only or read-write mode will affect your replication. The only problem is when you have a slave that is accepting write, you may lose you may end up having different data sets in master and slave. So if you try to failover this slave and promote it as a master, you most likely will need to take a backup from this slave and recreate the master with this data set. That is the main reason, because it's not recommended to use more than one server to write. And slaves are normally recommended to to offload some load from master, like reads or things like that, but never writes. Of course, using auto position and GTID will help to do this failover, but still, I don't recommend you to use slaves for write.
Okay, that brings us to the top of the hour. Like I said, I'm going to get these questions over to Francisco. And if he needs some clarifying information, he'll reach out to you to get that from you. With that said, Francisco, thank you for a fabulous webinar. We're getting lots and lots of good feedback. And audience, thank you so much for attending, and we hope to see you on a future show. Thanks again, Francisco.
Thank you very much.